now for doing the y. We're looking at F1 is equal to 5 kilonewtons, and it's right here, it's in that positive octant. If we take that value of 5 and multiply it by the cosine of 40, we find the component of F1 in this direction. And just as before, in order to find x, we multiply it then by a cosine of 50. Here, we take it and we multiply it by a cosine of the 40 degrees that's here. So this right here is 40 degrees. Because this is the y-axis, this is the x-axis, so you know that this right here is 90 degrees. If it's 50 degrees to here, then this is 40. So F1 times the cosine of 40 brings it down to the projection, and then that value multiplied by the cosine of 40, again, gives you the y component. So if we look at the PVC pipe, we take the value of 5 kilonewtons, we multiply it by the cosine of 40, brings it down to here, and then multiply it by the cosine of 40 again, and it brings us to get the value of the y. So now, let's set up the whole step by step. We're finding components. F1 is equal to 5 times cosine of x. In order to find the x component, it's F1 times the cosine of 40 times the cosine of 50i plus y. Cosine of 40 times the cosine of 40 j plus the cosine of 50 k kilonewtons. And that value comes out to be F1 is 5 times 0.4924i plus 0.5868j plus 0.6427k kilonewtons, and that comes out F1 is equal to 2.5i plus 2.9j plus 3.2k kilonewtons. And this is representing it in vector form. So how about our checks? 0.4924 squared plus 0.5868 squared plus 0.6427 squared equals 1, and it checks. 2.5 squared plus 2.9 squared plus 3.2 squared under the radical equals 5, and that checks as well. But now, if we wanted to set up, we have it in vector form, and we could write it in force, magnitude in unit vector. F1 is equal to 5 kilonewtons, and the unit vector of 1 is 0.4924i plus 0.5868j plus 0.6427k. So here's magnitude in unit vector. But how about if we wanted to have magnitude and direction angle? We have F1 is equal to 5 kilonewtons, and we know theta z is equal to 50, but how do we find theta x? How can we find it? If we know the unit vector, can't we say it's equal to the inverse cosine of 0.4924? And theta x turns out to be, let's find out, 0.4924 inverse cosine, 60.5 degrees. And let's find theta y is equal to the inverse cosine of 0.5868 equals 0.5868 inverse cosine, 54.1 degrees. And how can we check that? Well, the cosine of theta x squared plus the cosine of theta y squared plus the cosine of theta z squared is equal to 1. So the cosine of 60.5 squared plus the cosine of 54.1 squared plus the cosine of 50 squared is equal to 1, and it checks. So in this case, it's only for F2 and F3 that we actually can determine what all the direction angles are from the picture. But F1, we can't determine the theta. We can only determine theta z from here because the angles that are given are projections. And you'll see on the homework assignment that a lot of times we're given projection angles. And we have to use two cosines, two dot products to find a force at a certain, on a certain axis. The component of a force at a certain axis. Okay. All right, I'll see you the first day of class.